lot of work goes into determining how well fungicides work on soybeans in Nebraska. And every year, growers spend tens of millions of dollars putting fungicides on. Thanks to small plot trial research like this and on-farm research trials, we're going to show how well these products work, or even if they work at all. Come along with us this week as we take that combine we pulled out of the barn last week and take it to the field to harvest some of these small plot research trials. So what we just did is we went and prepped the edge of that field. We've got a border rows set up there. We got to chop those out so we can gain access to the field. And here's our first row. We're getting in there. Actually, we've already done some in this video, but we're going in plot by plot. And what we're doing now is we're in a plot. You can see here we're moving slowly through the field. Over here we've got a time lapse where we're moving much quicker, so you can see we go about 30 feet is the setup in these fields. The length between these sprinklers you can see is our plot length. We've got a gap in the middle we go over. We've got alleys between the rows where we'll stop as well and let clean out. So here's between a row, between an alley, or in an alley. I pick up that header and let any beans fall in. If we have beans get hung up, we've got a stick that we'll put in there so we can not be putting our own bodies in the equipment. Lodge any of those out of there so we can get that yield. Then we wait for the machine to process that, and then it'll fall down to the back where we'll collect it in a container. Here's that next plot. This is a small machine, so we're moving slow. We could probably move faster than this, but we're taking it easy on this. This also gives the machine more time to process, and we don't want to shove a bunch of material in there at once, so we can get consistent yields. So again, we're moving through a plot. We're coming up on the end of a plot right about here, and you'll see again I pick up and let that move to the back. Let that move through the header and give it some time to process. Looking down there at the person collecting seed, they give me the thumbs up. It's time. The seed has stopped going through, and then on to the next plot. We also have other fields. We've got other field sites. We've got other farms. Here's one of our farms. This is Haskell Ag Lab up in northeastern Nebraska. We do a lot of our white mold research there because this is an area that's heavily impacted. The whole state's not. This region is. So we go up there. Here's sort of our harvesting setup there. And again, you can see we're leaving behind. We're not taking every row. We take the two middle rows of each plot because each treatment we do, it's four rows wide. And in that field, they're 40 feet long. So we're collecting those two middle rows. That's what we're going to use to calculate the yields. And remember, these are the important factor here is that they're replicated. So we're just harvesting one plot in this video. Once we get to the end of that plot, we collect the weight. That combine in the video there is actually going to weigh them, do test weights to take moistures while we're in that plot. So it's recording the data as we go, which really helps, unlike our last setup where we're actually bagging it and then getting the data off of there later. Replication is what's key here, though. having replication so we can take those averages across multiple areas is important, because these fields aren't consistent. None of the fields are consistent. Your own field on your farm is not consistent. So if you put a check plot in on the edge, or a check row in on the edge, that edge might be very different than the rest of the field. So it's important to make sure that you get all of that. Now, this is a bigger combine. We just come in and clean the rest of this field out. Once we've got the data, this is how we get all the rest of those rows. Okay, so back to where we're harvesting this day. You can see here's what a finished trial looks like after we get out of there. We've got those edge rows that we're not harvesting. We also have border rows on the edge, on the sides of the field. And then on the end of the field, what I cut earlier were those other edge rows. All right, so that's it. That's how we harvest small plot research. It's slow, it's tedious. Someone's got to have the uncomfortable job of sitting on the back collecting all the beans. But we get it done, and we end up with a whole bunch of small bags of grain that we'll back calculate yield from. We've got to be really careful when we do this, because we're extrapolating that yield up to large acreages, and we want to make sure we get consistent measurements. One thing we do to protect against that is we do what's called replication. So here, if we're testing a fungicide, we will have a fungicide sprayed on that plot. But what we will also have is 4 different plots that have the same fungicide sprayed on it, and we're going to have 4 different plots that have a control or no fungicide sprayed on it, for example. And we'll go through, we will average all of those and then calculate the variance and do some math, and we're able to estimate what the true average is, as well as how certain we are about that average. That's the fascinating things about statistics, is we can calculate an average pretty simply, but we can also know how good of an average that is, and that's how we compare these, and that's why replication is so important. That's also why it's really nice to leave a check strip on your farm, but a check strip, it doesn't tell you how confident you are in that difference between the treatments until you get multiple check strips and multiple treated strips, and they all need to be randomized. Randomization is the key. So thanks again for watching. We appreciate you coming along and learning a little bit about how we do small plot research. I'd like to thank our funding agencies, the Nebraska Soybean Board and the North Central Soybean Research Program, for helping us get through another year of soybean research. It's an exciting time for soybean diseases, but it's a scary time as well, because we've got new stuff coming in. We want to make sure we're on top of it with research. We want to make sure that we're going to be ahead of these problems so we can solve these really before they start impacting large acreages. Thanks again for watching. If you'd like any more information about our disease program, go online to the disease section at cropwatch.unl.edu.